All righty. Good morning, guys. We're going to go over the Chapter 17 practice quiz today. This answer key we're going to go over today is already online, but we're going to do a live review of it. I'll mention some stuff with the formulas and how to use the Z-table and how to use the calculators for this stuff. So please stop me if you have any questions or email me, right? So question 1 says, according to Gallup, which is a company that does a lot of surveys, about 33% of Americans polled said they frequently experience stress in their daily lives. Suppose you're in a class of 45 students. Okay, so I'm going to stop right here. I'm going to go through what we have. So we have 45 students. So our N value equals 45. So I would read the question and right from the get-go, look at what they have, right? 45 students. Now, they said 33% of Americans experience stress. So we're going to use that as our p-value, okay, as in success, not as in having stress in your daily life as a success, but that's what we're looking for. That's like a person of interest that we're concerned about, and that's the success values. That's my p-value of 0.33. And then I'm going to go ahead and write my q value, and my q value is going to be 1, take away that 0.33. So if it's 33%, then the other part of people would be 67%. So according to the poll, if 33% are the people that do experience stress, oh my gosh, see, I say it and I write it. If 33% are the ones that do experience stress and the ones that do not on a daily life is 67% or 0.67. So they don't give us a standard deviation, but we can find a standard deviation using that little formula it said sigma is going to be the square root of P times Q divided by N. So I'm just going to make like a little note here on the side and say sigma is going to equal the square root of 0.33 times 0.67. Okay, and I will divide that by 45. So I'm not even looking at the question yet. I'm just going to go through and just write all my stuff out, what I know from the information given. So just from what is that? Two sentences. Okay, I have a lot of stuff here. I've got 0.33 times 0.67. Divide that by 45. And then I'm going to take the square root of that last answer. And I'm going to run this to 3 places, 0.070. So what do I have? I've got my N value, I've got a P, a Q, and a standard deviation. So on your problem, you should do the exact same thing. All right, so let's look at what the actual question's asking. The probability that no more than 12 students in the class will say that they frequently experience stress in their daily lives. So kind of what's happening here is if we know 33% of people experience stress and you have 45 people, you're like, you're one of 45 people, you could say, well, what would you expect? 0.33 times 45, you would expect about 14, 15 people. But what's the probability that no more than 12? So you guys understand kind of what the question's asking? Like, we wouldn't expect exactly 15 people or 14 people. It might be off by a little bit. It might be 12. It might be 20. It might be higher. It might be less. But if 33% of Americans frequently experience stress and you're around 44 other people, so 45 total people, the question's asking probability that it's no more than 12, that it's 12 or less, right? It's just less than 12. So it says make sure to identify the sampling distribution you use and check all necessary conditions. So that's kind of part of like the AP style question. We're going to kind of skip over that because I don't think anyone's been doing the AP test. But if you are, you should go through and write like a paragraph on all those little conditions. You expect, is it large enough? Is it random? Is it independent? So we're going to assume all those conditions are true and met. But if this was an AP test, you should kind of write all that stuff out, every sentence about that. All those conditions we talked about, you should go through all of those and say, Yes, it meets this condition. Yes, it meets that condition. Yes, it meets that condition, and go through that. I don't give a lot of space here. I'm not really going into that depth and detail, but just know we're going to be using the normal model. Okay, so we'll use the normal model, and the only way you should really reliably use this is if those conditions are met. Okay, but we're just going to assume they're all met. And when we use the normal model, we're going to look at the mean and standard deviations. The mean is the middle number, and that's going to be 0.33. We're going to use 0.33 as our mean, it's like our p-value. And then for our standard deviation is going to be that square root of p times q divided by n, which is 0.070. Okay, the reason why I put the 0 at the end there is because this number goes further out than just that, and it's rounded to 0. Like we cut off the rest of it. All right. So now what we got to do is say what we're trying to get to is a z-score. Okay. And with the z-score, we're going to be using these values, right? We're expecting 33% out of the 45. So what we have to do is find the proportion. What is 12 out of 45? And how does that compare to the 33%? What's that z-score? That's what it's all about, okay? So we're going to go ahead and say 12 divided by 45. And 12 divided by 45 is 0. We'll call it 267. And just kind of like as a frame of reference, right? Since they gave us 33%, what am I doing? Since they gave us 33%, we want to kind of just conceptualize that better, and that's 26.7%. So this is one of those kind of things, just kind of helps you out, I think. Even though probabilities, we always use decimals, it's just kind of nice sometimes to kind of pause for a second and say 12 out of 45 is 26.7%. Cool. Like it's less than the 33%. So what's that probability that it's 26? That's less than 26, 0.7%, instead of the 33%. All right. So doing this, we got to find our z-score. We're going to do this, take away this, divided by this. Okay. So we'll say the z-score of this actual proportion that we're trying to consider, 0.267. Take away from that what we would expect it to actually be, 0.33, and then divide that by the standard deviation that we found here of 0.070. When I calculate that, okay, and that's just a simple 0.267, take away 0.33, divide that by 0.070, I'm going to put all the stuff in, I get a negative 0.9. So that means that it's about 1 standard deviation below the mean, right? So it's not that crazy of a number. So what we got to do now, once you find the z-score, you should go to the z-table. Okay, so before I do the z-table, I'm going to set it up. I'm going to say the probability of having an observed value that is less than 0.267. Okay, I'm going to throw in that number there, that proportion of 12 out of 45. So what's probability of having a proportion that's less than this amount? Is the same as finding the probability of getting a z-score that's less than that number. So left side shaded, whoops, negative 0.9. So think about that. That's going to be like the whole like left side. Okay, if this is my middle number, it's going to be something like this. Okay, that left side shaded. It's the less than. Okay, so that's what we're thinking of with the less than value. That no more than. Okay, it's less than 12. So how do you calculate that? There are calculators for that. If we were in class, we would have the TI calculators. But we're going to go to our table here. And I'm looking for negative 0.9. So here's a positive 0.9. Here's a negative 0.9 all the way down here. And all the values here, you see how it says to the left of the z-score. Same thing here. It's going to say to the left of the z-score. So it's very important to understand that this is always the left side shaded is the standard way they give it to you. It's kind of like moving from left to right as it fills it in. Anyways, negative 0.9. Let's look at that. So it's just right there. This value right here is what we're looking for, right? 0.18406. Let's see. How should we round this? We just do it to that gave us 4 numbers. We'll run it to, sorry, they gave us 5 numbers. We'll run it to 4. That's pretty common for this at 10,000ths place. Okay, so I made that 406. I went ahead and just kind of looked at that 5th number, and I rounded up the 4th number up 1 to that 1. So this is my probability of no more than 12 students. But usually what we'll do on a question like this, we want to actually answer the question. We're going to answer it in a style of a sentence. I know it's math class, and this is one of those things that I always was frustrated at when I was a math student. Like, what do I got to write sentence? It's a math class. That should be for English class. So I'm going to go ahead and write this out. I'm going to say the probability of no more than 12 students, no more than 12 students experiencing stress daily is, now I have 2 options here. I can either write this decimal or I can write the percentage, and you could do either or. It's really, and on a problem like this, I think the answer key out of the book has it as a percentage, so you can write the percentage. I'm going to go ahead and write the percentage because the book did that. I think with a number like this, it kind of makes sense, since the question kind of has a percentage here, that you give them a percentage kind of back, that you would say 18.4%. Okay, and this is kind of the actual like formal answer to that. Okay, so I'm going to go ahead and go over that again. So I'll pause for a moment. And where did we start? Okay, this is where we started. They gave us a setup. They told us 33% of Americans said yada, yada, yada. That's our p-value. So whatever question you have for your actual quiz, that should be your p-value. Whatever percentage they start with is your p-value. Write that down. Okay. And then I would find your q-value from that. Just say 1 minus that. 1 take away 0.33 gave us 0.67. Okay. Turn that into a decimal. Sorry. Then reading along, it said an n value. They told you a number there. Don't use 12. Just look at the actual question here. Look at, just look at this stuff there on top. Okay, don't even worry about the question yet. Just from those 2 numbers, P and Q from that, N. Now that you have those 3 numbers, you can use the standard deviation. They don't tell you a standard deviation, but you figure it out from a sample proportion by doing P times Q divided by N and the square root of that, and we got 0.070. So all that information, those 4 important numbers, just came from those 2 numbers there. Okay. Now, reading the question, it says the probability that no more than 12 students in the class will say that they frequently experience stress in their daily lives. So that's a proportion, 12 out of 45, or less than 12 out of 45. That's that sample proportion. You're taking a sample proportion. Okay, and you're going to compare that against the 33%. And what's that probability of that happening? You got to think about finding a z-score and then using a z-table to get that probability. So this right here indicates we're going to use the normal model, and we're going to use our p-value as our mean, and we're right because we would expect an average of 33% of people with a standard deviation, the plus or minus of a 0.070. So this right here is stating how we're going to do our work. Then we find the proportion of what we're looking for, which is 12 out of 45, which we've got 0.267, which to kind of put it into like this kind of like in our heads, it's actually about 26.7%. So even though they say the national average is 33%, we're just kind of curious, well, what if it was 26%? And what would that probability look like? Okay, so doing that, we're going to do a z-table, and we're going to take this number that we found of the proportion, 0.267, take away the p-value of 0.33. So right now you should see that by subtracting that, it's going to be negative because it's under what we would expect. It's below the average, right? 26.7% is below the average. So you should expect a negative number here. Now, if this number was higher, let's say it was 36% or 46%, then you would have a positive z-value because it would be over the average. Okay. Anyways, we plug in that number, 0.267, take away from the p-value of 0.33, divide that by our standard deviation we found up here, and that was the 0.070, and we got a number, negative 0.09. Now, thinking about it, it's talking about this whole no more than 12 students. So this is the left side shaded, okay, which is going to be the true number from the z-table. Like that. That's why it's important. Okay. If it was the right side shaded, that's where it's the opposite number from the z-table, where you got to do the 1 minus the number from the z-table. That's only if it's right side shaded or a more than type question. All right, so how do we set this up? How do we make it look like what we're trying to do? We would say the probability of having an observed proportion that is less than 0.267, okay, that number right there. And then that is actually equal to getting a probability of having a z-score less than negative 0.09, so left side shaded. Then we went to our z-table, okay, and it was a negative. So negative 0.9 gave us 0.18406. You can write that full number out. I kind of like 3 or 4 decimal places personally when I do this stuff. I think the book has a z-table that goes to 4 places instead of 5. And so I went ahead and went to 4 places, 0.1841. Okay, and then I went ahead and I answered it in a complete sentence. The probability of no more than 12 students experience stress daily is 18.4%. So because this number was a pretty number, I mean, it might not look like a pretty number, but if it was like a 0.00 something, some crazy number, then I might just write the decimal version, which we might see later in this practice quiz. Okay, so once again, we're recording this so you can review it later. Question B says, if 20 students in the class said they frequently experience stress in their daily lives, would you be surprised? Explain and use statistics to support your answer. So we're going to do the same exact thing, but luckily we already have it kind of set up with our numbers. Those numbers up here won't change because we got those from the stats they gave us up here. Still 45 students, still 33%. So all these numbers here are the same. We're just going to change this proportion of 12 out of 45. It's now going to be 20 out of 45. And then after we calculate that, we'll talk about what does it mean to be surprised, okay? And when we say that, that's where we kind of go to the plus or minus stuff, the whole standard deviation thing. There's, like how far away it is from the average, right? Remember the whole, the 2 standard deviations out or 3 standard deviations out. So we'll discuss that in a moment. But in the meantime, to actually calculate it, we're going to use, instead of 12 out of 45, we're going to use 20. Okay, so this was for that number, but this is going to be 12 over 45. And 12 over 45, okay, so we say 12 divided by 45, and that is 0.26 forever. We're just going to call that 0.267, which if you want to put that in your head, oh, wait a minute, why did I do 12 again? Probably because I just said 12 like a billion times, right? I'm like, that number looks good. 20 out of 45. So please double check your answers as you guys go through this. So 20 divided by 45, that equals 0.4 forever. We're just going to call it that, which, put it in your head, is about 44.4%. So if the national average is 33%, and you got 45 people in class, and you would still kind of sort of expect 33%. But would you be surprised if 44% of the class had daily stress? Okay, so let's take a look at how we would do this. Once again, we are going to be using the normal model. Okay, so I'm going to state that. When it says use statistics to support your answer, that's where we would say write these kind of things out. If you don't, then you're not supporting your answer. So we're going to be using this stuff. We're going to be using the normal model. Once again, we're using the p-value as our average and using the standard deviation we already calculated as a standard deviation for our problem. Now we're going to find, so now we're just going to jump right to a z-score. Okay, so our z-value equals, remember how we did the 0.267 from that proportion? We'll do the same thing. Instead of 0.267, we'll use this new number, the 0.444. Take away our p-value, our average of 0.33. That stays the same. And the standard deviation of 0.070. Okay. If we were to calculate that, 0.444, take away 0.33, divide that by 0.070, and this says 1.6285. Let's just call it 29. So we've got a z-value of 1.629, which means, in context, that 20 students out of 45, given that we would expect 33% to have daily stress, okay, we would actually have 20 students, which we calculated to be about 44.5% of the class instead of the 33%. Would we be surprised? So the number we're thinking of here is, I would say if our z-score is equal to or greater than 2, or less than or greater than -2. Oh, good job. I hate when I write 2's differently in the same thing. So basically, you want your z-value to be between -2 and 2. We say that that's 95% of your numbers, right? Remember the whole 68, 95, 99.7 rule, okay? The whole normal distribution, right? We are using the normal model. We're assuming that we can use this based on those conditions that we assumed already. So since we're assuming a normal model, we would assume that 95% of our numbers that we would expect to be a nice, easy, normal, regular class should fall within the plus or minus 2 standard deviations. So once it kind of gets to 2 and beyond, that should rarely happen. Okay, that shouldn't really happen. And when it does, you might want to find out what's happening. Like that would be a cause of concern that you should kind of try to understand more about. Usually in life, we don't care about the middle stuff, the boring stuff. And so this would just be a boring answer. Okay, so since this number falls between those numbers, -2 and +2, we're going to say that we're not going to be surprised. We would only be surprised if it was greater than that. In fact, I think I use a Z for surprise because I'm awesome like that. I'm going to not do that. So because I found this answer here and it falls between those numbers there, I'm going to say 20 students would not be a surprising result. Would not be a surprising result. So once again, explain and use statistics to support your answer. Here's me explaining it. This is my stats to support it. So if you do not do that, if you do not support your answer, okay, if you do not support your answer with statistics, then that question will be wrong. Okay, you have to have numbers to support your answer. All right. So the last question now, we're going to kind of reset. We did all this kind of stuff for this question. Number 2 is going to be a little bit different, though. Number 2 is going to be slightly different, but very similar, as in we're going to use a z-score, but they give us a different set of information. Okay, it's no longer a proportion. It's no longer 33% or something. It's going to be a little bit different. They say the average composite ACT score for Ohio students who took the test in 2003 was 21.4. Okay, so that number 21.4 is an important number. We're going to use that as our mean, as our mu. They're giving us some definite number here. Okay, assume that the standard deviation is 1.05. So we're going to assume that the actual standard deviation is 1.05, meaning if you picked a random student in Ohio, in Ohio, and you asked them, hey, what was your score on the ACT back in 2003? Okay, you would expect it to be around 19 to 23, 24, somewhere around the 21, plus or minus a little bit. If they got like a 26 or 27, or they would be way above average. If they got like a 15 or a 16, they're probably kind of far below average. But we would expect most students to score around, what would that be, about a 19 to about 23, right? That's what we would expect most of our numbers, plus or minus 2 of these. Okay, you pick 25 students. So now that we're not looking at one student, now that we have 25 students, that was that formula we talked about that said our standard deviation of that y bar, that was going to be the sigma divided by the square root of our sample size of 25 students. So square root of 25. When I calculate that, okay, I'm going to say 1.05 divided by a radical 25, which is just 5, we get 0.21. That is a pretty number. So one more time. We are not going to use this right now. We're going to use this new standard deviation because we're going to pick 25 students and we're going to be doing the average of all of their scores. So now you're kind of like, there should be less variance. Their average should be closer to this average. Okay, each one of their individual scores might be like 22, 23, 19, 24, 18, 20, 21. You're going to get 25 students. Their whole average should be pretty close to 21.4 when you average all of their scores out. Okay, that's why your standard deviation is now going to change, because you would expect their average to be closer to this. This standard deviation is for one student. This standard deviation is going to be used for 25 students when you group them together and you find their average. Okay, so what's the probability that the average composite ACT score is 22 or more? So we want to know, we're going to do a new z-score. Okay, we're going to say a z-score where we take this number, 22, and compare it against this 21.4 with this new standard deviation. Whoops, 0.21. So one more time. Remember how we kind of took like this number here and we compared it against the 33% average? Okay, it's kind of the same thing. This number here that we care about, compare it against the true average of 21.4 and see what's that, probability of happening. When I do that, let's calculate that. 22, take away 21.4, divide that by 0.21. Make sure you're using order of operations, please. We get a z-value of 2.857. I'm going to go ahead and just make that 86, because on my z-table, it's usually only the two decimal places. So the probability of having, I should use a y-bar. Your y-bar, which is greater than, right, 22 or more. Okay, so this is going to be the right side shaded. Okay, so once again, if this is your z-score, okay, this is like 1, 2, 3. If we've got, it's going to look something like, probably like over here. It's going to be something like a little small piece right there. So I'm assuming it's going to be a small probability. Okay, it's 22 or more is the same as having the probability of getting a z-score of greater than 2.86. Okay, so z-score, z-table, but be mindful it's right side shaded. This says left side shaded, so you got to do a small trick to fix that. So left side shaded, 2.86 positive, 2.86, 2.80. 1, 2, 3, 4, 5, 6, right? This is 2.80. This is 2.81, 2.82, 83, 84, 85, 86. So I'm going to do some quick little math here. I'm going to say, let's go back to this. Let's say 1 take away 0.9978. Whoops. Okay. So really what this is that answer right there. It should be a really small number, which is 0.00212. I'm just going to write that out. That's the probability of getting 25 students. Right. So if one student got a 22, that wouldn't really be surprising. But if you get 25 students and you find their average, it should be really close to 21.5. Okay. They say with 25 students, it's highly unlikely that their average is going to be 22 or more. Okay. So I'm going to write this out as a statement. Okay. I'm going to write this out in a complete sentence and say the probability that 25, random students had an average of 22 or more is. Now, since this is a small number, if I was to make this a if I was to make this a percentage, it would be 0.2%, which is a really small number, which you could write that, and I could do that right here. But because it's a really small number, I'm just going to keep that like this. That's kind of like it seems to be the standard. And I'm just going to round to 10,000. So I'm going to cut off this last number here. So a very small probability that 25 students, their average would be 22 or greater. It's a really small probability because I would expect maybe one student, pretty likely they'll have a 22, 23, okay, 24 maybe. But if you pick 25 independently random students, not like they're 25 students that we know are these high honor students that might have a higher average, just 25 randomly selected students from Ohio during this school year, okay, their average should be really close to 21.4 given this information because it's 25 students, right? Their average should be close to that. However, this is the answer for 22 or more, okay, for a score of 22 or more. So as you see, there's some similarities, okay, using the z-table, finding the z-score, but there's some slight differences between these two questions. So I'm going to stop the video right now. If you guys have questions, I will be here and be available. Email me if you have more questions. Let's stop the recording.